Okay, so this is week 2, assignment 2. These are the missing view problems. You're given 2 views, and you have to solve for the missing of the third view of the orthographic view set. So re-sketch it. I'm using a number 2 pencil. I'm finding that this is really the way to go. You can get a nice dark thick line without a lot of effort. So this works actually better for sketching than a mechanical pencil. Nice soft lead, dark line, that's what we want. Okay, so we're going to use the numbering technique to visualize, to do this, okay? And how we're going to do this is we're going to name some planes and find them in the other view, but we're going to start with inclined planes, okay? The numbering technique, get that up there a little bit. Whoa. The numbering technique is used to visualize or to help you solve for something that you have a hard time visualizing. So, first thing we have to do is find the inclined plane. An inclined plane looks in an orthographic view as either a contour, if you're looking toward the inclined plane. If you're looking down the edge of the inclined plane looks like a diagonal line. So we have one diagonal line here, one inclined plane here that's facing to the right side, and we see it in EdgeView. We have one diagonal line here facing toward the front, and it's in EdgeView. And we have one diagonal line here that is in EdgeView from the front view. And we're going to be able to see this from the top, okay, as a contour. From the right side, we can see this as a contour, and this one we'll see in the front view. Looking this way, we'll see it in the front view. Let's take one at a time. This is the numbering technique. That's going to fit up there. Numbering technique. Okay. I can only go over to about here. Okay. So the numbering technique is in the PowerPoint notes, PowerPoint from week 1, 2. And it spells it out for you. It's like a walkthrough. It explains step by step by step. It's easier to understand it if you see somebody create it or use it to create a picture here, an unknown view, than to read through it. But if you get stuck, you can go through the step by step and read through it and figure out how to go. Okay, this is the process we go through. First, after you've drawn the 2 views given, and make sure they are correct, okay? Make sure they are to the right proportions and that you didn't miss any lines. So we're going to pick a diagonal line. We'll pick this one. I'm going to point to it and label it A. That is plane A, edge view toward us in the front, which means we can see it in the right side view. We'll show it because it's leaning or facing toward the right side. So what we're going to do is we're going to say, okay, well, let's project the top of A over like this and the bottom of A over. And now we know that in the right side view, since we're looking this way at it, we know that plane A is from here to here, bottom to top, 6 squares high, and it's going to be a contour. It's going to be a shape, not just an edge view, not just a line. In the right side view, it's going to be a shape. So we're looking for a contour from here to here. Do you see that contour? So this is A. Pretty easy, right? That's the shape of A. Here it is in edge view. We then pick a point on A, number it, 1. I will number points by letter planes. So we pick a point, any point, and you go consecutively around either clockwise or counterclockwise, doesn't matter, and you number it. 1, 2, 3, 4, 5. I might make my numbers a little bit big just so you can see them. So it might get a little sloppy. 9 sides. So plane A has 9 sides and 9 points. We've defined the points on A by numbering it. We are now going to take those points and put them in the other view. So we're going to project them straight back to the front view. 1 and 2, points 1 and 2 are somewhere along this projection line. And they're on A. So right there has to be 1, 2. 1 and 2. 1 in front, 2 in the back. So I label it 1, 2. Technically 1 is in front of 2. If you label it 2, 1, it's still going to solve the same way. Down here is point 9, 3, and 4. So right across here on A is 9, 3, and 4. 1 square down is 8 and 7. And then 1 more down is 6, 5. See that? Now anytime you find any point on a plane, any point in space in any 2 views, you can find that point in space in the 3rd view. So we're going up to the 3rd view and we're going to find A up here. This is the solution we're looking for. Somewhere up here is point 1 and 2. Somewhere up here is point 1. Hit the miter line, turn 90 degrees, come across the projection line, and where it intersects the other projection line, that is point 1. Has to be. Point 2 is up here and across. Point 2 is up here. There's point 2. Point 9 is somewhere right here. It's not on a grid line. It's halfway in between. So make sure you might have to draw a little projection line. Now point 9, we project it up and over where it intersects the other projection line for point 9. Put a little dot, label it. 8. See, where's 8? Right here. So 8 project up and over is right there. We don't have to think, we don't have to visualize. Your imagination, your visualization of this top view, in order for you to visualize that, you have to take the data you're given, you need to construct it in your head, in your imagination, in your mind, into a 3-dimensional object. You then need to rotate the object upward and only look down at the top in your mind and see plane A there and draw it. That's difficult to do. So this lets you solve for the problem without having to visualize it 3D in your head. Because of all the tools I teach you, we're doing projection and numbering. Of all the tools I teach you, your imagination is the worst tool in your virtual toolbox. Your imagination will send you down the dark path, okay? And you will fail as often as succeed. Your imagination works best as a checking mechanism. Once you get all the data, as much data as you can figure out, then you look at it in your mind's eye and you say, you look at it actually physically and you say, does that look right? Okay? So your imagination is better to check your work than to solve for work. Okay, continuing on, 6 and 7 are along this projection line, so I'm going to put my thumbnail there. And I'm going to go, let's see, 6 or 7 is right here, it's along this one, and there, so that's 7. And 6 is right there. That's 6. What do we got? We got 3. We're following around 3 until we find 3 right here. And 4 and 5 are in the very back, so put my thumb there. And here is 4. And on the far right side is 5. And if I did this right, and if you want to, you can erase construction lines, no need to, and projection lines, is you connect the dots. Try and keep your lines straight. 1, 2, 3, 4, 5, 6. This is why it's imperative to number your points consecutively. When you get to 9, you go back to 1. There's A. So when you're numbering consecutively, either clockwise or counterclockwise, you number around the perimeter. Don't number from top down. Don't say 1, 2, 3, 4, 5, 6, 7, 8, 9, or you won't be able to connect them consecutively. So there's plane A. Didn't take us having to visualize it. It just appears as if by magic. Let's do it again. For these homework assignments, you're given the 2 views. You have to solve for the 3rd view. You have to use the numbering technique. It's that good of a tool, so I require you to use it at least once. And this one we're going to do 3 times, because it's kind of like a jigsaw puzzle. How do you solve a jigsaw puzzle? You start off by doing the corners and the sides, right? Because that's the easy way to do a jigsaw puzzle. I guess you could start in the middle if you wanted to with a 500-piece puzzle. That's stupid. Okay, so you do the easy stuff first. So we're going to do inclined planes first. Let's point to the next inclined plane, B. This one, what do we know about B? It is facing forward. If you look at it from the front, you will see B as a shape, the contour of B. We know that it is 1, 2, 3, 4 units high, and it's facing the front, which means the front view should have a contour from the top down 4 units. Top down 4 units, there's B. Now we already know 2 points on B. We know point 1 and we know point 9. There's 1, there's 9. I can reuse those. 1 and 9, 10, 11, 12, let's see, 11, and 13. So B goes 1, 9, 10, 11, 12, 13, back to 1. That's the perimeter of B. We've defined the perimeter by those points, 6 points, 1, 2, 3, 4, 5, 6. We're going to project them back. We already know 9 and 1, but we're going to project 11 and 12 to the edge view. And it has to be on B. It's not 11 and 12 or 12 and 11. Both 11 and 12 have to be on B, which is an edge view line. So this is 12, 11. 10 is going to be behind 9, 10, right there. 13 has to be right here by 1. Once we find all the points, we can project them. So 13 comes up here, over here. Put my fingernail on that line. Here is 13, right there. 13. Hope you can read that. Continuing on, 10. It doesn't matter which one you find first. 10 is across here, right to there. There's 10. 11 and 12, project up and over. Put my thumbnail on that line. Here's 11. Here's 12. Connect the dots. We already have 1 to 9. 10. 11. If you don't have a soft pencil, you're going to have to press hard on this 3 or 4 times and go back and forth. 12 to 13, 13 back to 1, and there's B. Third inclined plane, back here. C, we'll call it C. What do we know about C? Well, we'll be able to see it in the top, so if we're looking down, we'll see the contour of C. It is, but we don't, if we look at it from the right side, well, it's behind A, right? So it's over here. It's going to be invisible. It's going to be hidden. C is hidden from the right side. We have a right side view. We know it's 2 units tall. From here, 13 down to 12 vertically. And it's going to be hidden. So C in the right side view, we can see the bottom of C. That's that hidden line. The rest of C is actually hidden lines underneath these object lines, underneath A. But we can still physically find it. So C, and we'll circle it, is in the background. Okay? It's in the background. It's 4 sides. So we already know what's on C. We know 12 and 13. So we have 13 and 12. We're going to go 12, 13, 14, 15. 12, 13, 14, 15, back to 12, which means 15 is on this projection line, back on C, and 14 is directly across. Again, has to be on C, 14 is there. So 14 we project straight up, somewhere on this vertical projection line. We go up, over, there's 14. Erase our projection line. 15, we go straight up. 15 goes up and over. There's 15. Oops, not 13, 15. So 12, 13, 14, 15, back to 12, and that is C. Look what we've done. We've solved 80% of the top view, and I didn't have to visualize at all. Okay, did not have to visualize. That's the power of the numbering technique tool. Okay, since we found all there's only three types of planes. Okay, there is a normal plane. From the PowerPoints, a normal plane. Where's a normal plane? What do we see as a normal plane? A normal plane, if it's a horizontal plane, we see it in the top view as a contour. In a horizontal plane from the front, looking from the front is an edge view. Looking from the right side is an edge view. So a normal plane gives you two edge views. In a three-view set, a normal plane gives you two edge views and one contour view for each inclined plane. A, contour, edge view, edge view. Oh, so that's an inclined plane. Here's a normal plane. If we call it D up here on top, okay, the very top, it's got edge view, contour. So there's a normal plane. If we have an inclined plane, inclined. What does an inclined plane look like in a set? Okay, here's a contour view, shows a shape. Contour view shows a shape, and one edge view. So for an inclined plane, we have two contours, one edge view. Okay. The other kind of plane we have a curved plane. If you have a curved plane, it's going to be similar to a inclined plane. There's going to be two contours in the three-view set, and it's going to look as an edge view once. If you have an oblique plane, you don't find oblique planes too much in our homework. Okay, oblique plane gives you three contours. You will see all three plane that plane as a contour in all three views. Okay, so it's nice to know sometimes what you're looking for. This is in your PowerPoint notes too. You don't have to take too many notes off the PowerPoint notes in the reading assignments. You know, whatever you feel comfortable with. But this is important to remember. It's one of the slides in your PowerPoint 2 notes also. Okay, so what do we have to do here? We've got three inclined planes. We're out of inclined planes. We found all the diagonal lines, so we're out of inclined planes. That means most likely all the planes left are going to be normal planes, unless there's no oblique plane in there. But an oblique plane will be a contour with all the same number of sides in every view. Usually pretty easy to spot. How do you find, okay, looking at down from a top view, we want to solve for any horizontal planes because they're horizontal and they're contours in the top view. What does a horizontal plane look like in the known views? Well, a horizontal plane looks like a line, just a line. So this line is possibly a horizontal plane. It's kind of like the edge of the roof of a house, okay, the peak of a house. This line either represents an edge view of two planes or a plane in EdgeView. So either it's the edge of two planes, or it's a plane in EdgeView. If it has a depth to it, then it's a plane in EdgeView. So let's project over to the right side. Yes, that line does have a depth to it. So it is a horizontal plane that's too deep and too wide, and we can project it up and over the depth of it and the width of it right up here. So a line right there is plane D. Next line down is this line. Is this an edge between two planes, like the roof of a house? Or is this a plane in EdgeView? Well, if it has a depth, we'll see the depth in the other view. We project over, and here, this must be that same feature, this hidden line. So there is a depth of 4 and a width of 4. Well, here's the width, and here's the depth. Project these 2 points up and over, and you will get this for your horizontal plane. We'll call that E. So this is E. This line here is E. Now we have one left. Well, we have a couple left. We have this one here, F. Is that an edge view of a horizontal plane, or is it a plane in EdgeView? Maybe this line, that F, is right here. How much of this is a plane? Or does it drop off right there? Is this a vertical plane right here? If it was a vertical plane, if that dropped off right there, it just like sloped up and then dropped straight down, there would be a hidden line here showing that edge. There's no hidden line. There's also no hidden line horizontally right here. There would be a hidden line. Well, it's behind the object line. So we can't see how long this plane is. This is plane F. Well, let's see. Let's make some assumptions. What if F dropped off? What if it went to the west and it stopped here? Well, if it stopped there and dropped off, then there'd be a hidden line. There is no hidden line. Well, there is a hidden line. It's all the way to the end, and that's where it drops off, and the hidden line is underneath this object line. Okay? One more. Well, here's a horizontal line. This horizontal line, let's call this plane, what are we up to? F. Let's call this G. Call a contour G, name it in another view. Well, let's see. G is 2 units high, so it can't be this shape. That's 3 units high. This line, though, is only 2 units high, so that's G, which means G is a vertical plane facing to the right. That's a normal plane. Then this one, H, must be this line. All we have left is horizontal and vertical planes, okay, normal planes. So that's H right there. Where's H in the top view? Well, it's an edge view here. In the top view, it's going to be an edge view too, right? Contour, edge view, edge view. Contour, edge view for a normal plane. So all of the points, you can't really, if you numbered H, you'd put all the numbers here. You're just going to get another line when you project them. So H is how long? It's 12 units long from the left side all the way to the right. H would actually be, let's label it and circle it. H is this shape here. There's a hidden line that represents the edge. I'm sorry, that's not H. Edge view, right? This is H. This line. Part of it's visible. Part of it is hidden. It's a hidden line. Part of it's visible in the drawing. Part of it's underneath this object line, and it goes from here to here. Actually, it goes from here to there. That's H. Okay, it's a vertical plane in the top view. Vertical line in the top view. So that's H. This one here, I don't use I because it looks like a capital H too much. So I'm going to use J. J is this line. It's a horizontal plane. Here it is in the front. We know the width of it. It goes over to point 8. We know the depth of it. Here's the back of it right here. So this rectangle that I put these lines in, this is J. Okay? It's hidden from view. But whether we found J or H, we found that hidden line. That's why it's important to label all your planes. If you label all your planes and find them in every view, you will find all your lines.